This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please do not share personal information during the class for your own security reasons. So again, we should have our ticket open and ready to go. Password is in the chat box for you as well with the link. So just waiting on a green check from Jeremy, Sienna, let's see here, Vega and Seha. Make sure I get your green checks. Hi Sienna, welcome to class. Sorry, I know you just joined us. Go ahead, open up your ticket. Get it ready to go. Excellent. So there's only 2 days left of the quarter, guys. We've got tomorrow and Monday, and then you guys get a little bit of a break. Remember, you get Tuesday and Wednesday of next week off. And then you'll come back for quarter 2 on next Thursday, so a week from today, and you will be getting completely new classes. So some of you might have part 2 of physical science, so you might have me again. But if you don't, I will definitely be missing you guys because you guys are really awesome. But today we are going to go ahead and power through our final exam part 1. Remember, this is the multiple choice portion. Tomorrow we will do the short answer portion. So today, multiple choice, that means that they're pretty easy questions, but there's going to be more of them, right? There's 25 of these ones, whereas the short answer, there's only 3 of those. They're just each a little bit harder individually. Smiley faces if that makes sense. Again, it is a 2-part exam. You want to make sure you're here today and tomorrow. Smiley faces all around, please. Perfect, looking good. All right, let's go ahead and jump right in then. So today our objective again is to basically go over everything that we've learned so far the entire quarter. So we're going to be talking about how matter and energy interact. We'll talk about the laws of motion again. We will review force and the different types of forces, talk about work, energy, and power and how they all interact. We'll also talk about different types of waves, right, both mechanical and electromagnetic. And then our most recent units, we talked about electricity and magnetism, so we'll also do a quick review of that. And sorry, I don't know why this still says the 5D assignment. This is actually the 10A assignment, so we're going to be doing the 10A final exam. Okay, so that being said, guys, today we're not going to really focus on the attendance ticket very much. You should already have it open, but basically we have 2 questions on it. And the first question I'm going to do right now. The last question, as always, I do during the last minute of class. So you'll be able to do this question, save it, and then set it aside till the end of class. So what we're going to do, though, is I'm going to also have you actually open up your final exam. Okay, so you will have 2 of these open. Okay, so here's your final exam as well. If you're watching the recording, you go to the Content tab, find Unit 10 on the left side menu, scroll down, and find where it says the 10A exam. Okay, now really quickly, guys, the final exam is the largest grade in the entire class. Remember, it's 2 parts, so both parts together make it a gigantic grade. So we want to make sure that we complete it right away because we don't want our grade to suffer because I will be entering zeros once it's due. Okay, that doesn't mean that you can't still do it. It just means that you'll see a 0 until you get it done. Smiley faces if that makes sense. Okay, you still get full credit even if you turn it in late. It's just your grade is going to feel it until you actually get it turned in. And you might not be happy about that. Your parents might not be happy about that. Okay. Now today what's going to happen is I'm going to go over the information and then I'm going to give you a minute. Okay. Now during this minute you can do one of 2 things. You can either take a picture of it so that you have it saved for later, or you can answer it very quickly. So if you're a fast test taker, have it open and answer it very quickly. And either way, you need to give me a green check. So once you have your picture or once you have answered and saved it, you need to give me a green check. Thumbs up if we understand. Okay, 2 options, take a picture or answer it and save it. But both options, you have to give me a green check. Awesome. Now, just like our midterm exam, it's a little bit too long to go over every question right now in class. So I'm going to go over the hard questions in class, and then the easy questions are in a video I will give you. And that video is only 10 minutes, so it's super easy, guys. Okay, super, super easy to make sure you get those easy questions done at the end. So again, we will be going out of order. We will be jumping around in the exam. So you'll have all the hard questions answered by the end of class. I'll give you a video, 10-minute video to go over the easy questions. Okay, very, very easy. Awesome, guys. So at this point, go ahead in your ticket, please answer question number 1 and give me a green check when you have number 1 saved in your attendance ticket. Green checks when we have number 1 saved in our attendance ticket. 15 more seconds. Just waiting on Dalen, Grant, Jacob. Let's see here. Hi, Johnny. Welcome to class. Please open up your ticket and answer question number 1. Mikey, you as well. Awesome. Hi, Frankie. Please open up your ticket. Link and password are in the chat box. And then answer question number 1. So the final exam is the largest grade, and we need to complete it immediately. Okay. And then, awesome, guys. Remember, I also do need you to also have your exam open. So give me a smiley face if you also have your exam open. So smiley face if we also have our exam open. Okay, so again, you should be answering question number 1 in your ticket, and then a smiley face if you have your exam open. That's the second link in the chat box there. Okay, yeah, if you just turned labs in, Johnny, I won't have graded it yet. I updated all the lab grades on Monday, but if you turned it in after that, you won't have gotten a grade on it yet. Cool. Hi, Jasmine. Thanks for joining us. Hi, Ciara. All right, guys, looking good. So again, we should have answered question number 1 in our ticket, and we should be ready for our exam. Link to the exam is in the chat box. Okay, guys, so, okay, no worries, Ariana. As always, you can take a picture. Another option is, as long as you have saved your attendance ticket, you can actually close it right now. Make sure you have the password saved, written down somewhere. So you can actually close your attendance ticket and open up the exam instead. So that's a really good option as well. Okay? Cool, guys. All right, so we are in our 10A exam, and you will see that it has 25 questions. Again, we're going to be jumping around. Okay, Ciara, I'll go back to it later. We're going to be jumping around between the questions. Again, I'm going over only the hard questions in class. There's a short video, 10 minutes, that will take you through the easy questions at the end. All right, guys, so question number 1, we're starting at the beginning. So graphing. Remember, graphing helps us determine the relationship between 2 variables. And those 2 variables are the independent variable, which is what we start with, or the cause of our experiment. So for example, if we're trying to melt honey and make it flow faster, temperature would be the independent variable. That's what we're in charge of. That's what we can change. And we plot that along the horizontal axis. So right here along the left-right axis. The dependent variable, on the other hand, this gets plotted on the vertical axis. So you can see that right here. And this is the result or the effect of our experiment. And so this gets, this is the dependent, the kind of end of our experiment. And again, that gets plotted on the y-axis. So at this point, again, you are in your exam. Please answer question number 1 in your exam. Give me a green check when you have it saved. You only have 1 minute. Either take a picture or answer quickly. Go, go, go. "15 seconds left. Still waiting on a green check from Annalise, Ciara, Dalen, Grant, Haley, Jacob, Jasmine, Maya, and Ty. Again, I'm only giving you a minute, and then we're immediately moving on because we don't have time to waste, guys. All right, so we are now going to go over both question number 2 and question number 22. So again, we are hopping around. Currently, we're going over the hard questions, so we are skipping a few of them. Don't freak out. Those easy ones that we're skipping, I will be giving you a video at the end of class. 10 minutes, super short. Question 2 and question 21. You can see it up here in the blue box. So we're going over 2 questions, number 2 and number 21. Yep. Okay, so really quickly, levers. Remember, levers are a bar, a stick, or a board that rotates around a point, which is called the fulcrum. So the fulcrum is where we pivot. Okay, now if we change where we have the fulcrum, this changes the amount of force or effort that we need to input into our lever to do work. So we can see a couple examples of levers down here. The first type of example is the seesaw example, where the fulcrum is in the very center and our force is going to be opposite of the load. So this is exactly like a seesaw that we see up here. Our second example is our wheelbarrow example, where we have, for example, the fulcrum at the very end and our force is at the very opposite end. Okay, so this is like picking up a wheelbarrow. And our last example is like a tweezer, where again the fulcrum is at the very end, but this time we put the force in the center to kind of like squeeze the load at the very end. Okay, so again, changing the fulcrum changes the amount of effort or force that you need to input. So taking a look at that, again, reminding ourselves what the fulcrum is, take a look down here, which of these would be the fulcrum? Where are we actually pivoting? Ciara, don't worry about the attendance ticket right now. We are working on the exam. Everybody needs to open the exam. Okay, which part here are we pivoting on? Which part is the fulcrum? Awesome, yes, you guys are correct. So letter B here is going to be our fulcrum. That is where we're pivoting. Okay, this is number 2 and number 21. You have 1 minute. Either take a picture or answer and save quickly. You only get 1 minute and then we're moving on. I need green checks from everyone. Go, go, go. All right, waiting on a few more green checks. Again, green checks if you have answered number 2 and 21 and saved them, or if you've taken a picture of the slide. So Annalise, Brianna, Ciara, Dalen, Dolly, Libby, Frankie, Jacob, Jeremy, and Johnny. Need green checks all around. Again, we are not wasting time today, guys. I really need your green checks right away. Please don't be messing around. Make sure I get your green checks. All right, I'm moving on. Looking good. All right, guys, so the next two questions are talking about buoyancy. Again, if you just joined us, we are skipping around because we're only doing the hard questions in class. I will be giving you a link to the easy questions. It's 10 minutes to answer the easy questions. So right now we're skipping around, okay? So question number 3 and 10 are talking about buoyancy. So remember, buoyancy is the upward force that causes things to float. And this upward force is dependent on an object's density and the fluid's density. So here's the thing, guys. If you know the density of a fluid, when there's an object floating in that fluid, you can actually estimate the density of that object. So for example, water's density is 1 gram per milliliter, and ice's is 0.97 grams per milliliter. So what this number means is that if we convert this into a percentage, what is 0.97 in a percentage? Tell me in the chat box. What is 0.97 in a percentage? Tell me in the chat box. Yeah, exactly. It's going to be 97%. So what this means is 97% of the ice will sink. Smiley faces if that makes sense. So you just turn this into percentage, and that's the percent that sinks. Okay? That obviously means that the other part is floating. So only 3% of it is flowing. So for example, can everyone else hear me? Sorry, I can move the mic. All right, can everyone else hear me? Okay, Ciara, you might need to take the slider that's on your speaker and move it all the way to the right in the audio and video box. And also make sure your computer volume is turned up. Okay, so taking a look down here, for example, if we have a object that's 0.75 grams dense per milliliter dense, what would that percentage be that sinks? Tell me in the chat box. Turn that into a percentage. Tell me how much sinks. How much will sink? Turn it into percentage. Yeah, exactly, a 75%. Okay, so guys, this answers both question number 3 and number 10. Again, the part that's sinking, it's the same density as percentage. Okay, percentage sinking, percentage, and the amount of density is the same. So answer number 3 and number 10, you have 1 minute. Give me a green check when you have both of them saved, or if you have taken a picture of this slide, give me a green check. Ready, set, go. Perfect. Waiting on green checks. Annalise, Brianna, Sienna, Ciara, Dolly, Haley, Jacob, and Jasmine. Green checks. Moving on. Okay, guys, so question number 4, again, going back to question number 4, was talking about motion. So remember, motion is how we go from one place to another. Now, there are 2 terms that we learned that are similar but a little bit different. Remember, speed just tells us how fast an object is going, but velocity actually gives us both the speed as well as the direction. So whenever direction is included, that means we're also including velocity, or that means it's talking about velocity. Smiley faces if that makes sense. Okay, when we talk about speed and direction, that means we're talking about velocity. So for example, when you say a velocity, you have to say 3 meters per second to the right, or positive, or 3 meters per second to the left, or negative. Okay, whereas speed would not have positive or negatives because direction doesn't matter for speed. Okay, this is number 4. Give me a green check when you have it saved or you've taken a picture. You have 1 minute. Ready, set, go. 15 seconds, waiting on Brianna, Sienna, Ciara, Dalen, Dolly, Libby, Frankie, Haley, Jacob, Jasmine, Jeremy. Green checks, please, and we're moving on in 5 seconds. Awesome, here we go. Okay, so question number 5 is talking about acceleration. Remember, acceleration is the rate of change in the velocity of an object per second, okay? So this means that if we have positive acceleration, again, that means velocity is changing in the positive direction, so we're increasing our velocity. On the other hand, negative acceleration would mean that we're decreasing our velocity, so we're stopping or slowing. Up here, we're getting faster or starting. any change in velocity, that is acceleration. This is number 5. Give me a green check when you have it saved. You have 1 minute, or take a picture and give me a green check. Go. 10 seconds, waiting on Andres, Ciara, Dolly, Frankie, Haley, Jacob, Jasmine, Jeremy, and Seha. Green checks, please. And I'm moving on. Let's keep going. Okay, so we're skipping a few questions. Again, the questions that we skip will be in the recording for the easy questions. So don't freak out. I understand we're skipping 6 and 7. That's okay. We will go over those in the video for the easy questions. So right now, go ahead, scroll down to question number 8. Question number 8 is talking about refraction. Smiley faces, if you guys remember me putting the chopstick in the cup of water and the chopstick looking like it was broken once it was in the cup of water. Remember, yes, this is what's called refraction. So remember, light bends when it enters a substance, and this actually slows down the light. So the result is, for example, in water, light travels much slower than it does in the air, and as it bends, that means it causes objects to look different underwater. It looks like they're broken, or it looks like they're in the wrong spot. So that is refraction. This is number 8. Give me a green check when you have it saved, or a green check when you have taken a picture. You have 1 minute. Go. 5 seconds, waiting on Audrey, Sienna, Daylin, Dolly, Haley, Jacob, Jasmine, Michael, and Seha, and D-Bob. Okay, yeah, no problem, Brianna. Give me 1 second. Here you go. All right, guys, looking good. Let's keep on going. Okay, so question number 9 talks about non-contact forces, and there are 4 of them that we learned. So remember, gravity is the force that acts between all objects, and it's based on mass. The more mass you have, the more attractive you are. So for example, the Earth, that is very massive, has a ton of gravity. You and I, on the other hand, are not nearly as massive as the Earth, so while we still exert gravity on others, it's just not nearly as much as the Earth, okay? But remember, you are always attractive, okay? Now, electromagnetic forces, these are the forces between 2 moving charged particles, and this is what, for example, keeps electrons near our nucleus, and as we talked about in our most recent unit, this is actually also what creates magnetic fields, is moving particles. Now, intermolecular forces are the forces that attract different molecules to each other. So for example, when you have 2 separate water molecules, the positive hydrogens on one of them are attracted to the negative oxygens on another. And this results in really strong surface tension on water, which is why, for example, we can pile a bunch of water onto a penny without it actually spilling over. This is why we get things like raindrops instead of just flat water. Okay, raindrops have a curved dome, unlike if it had no surface tension. Okay, and lastly, strong nuclear force is the force that holds the nucleus of the atom together. Remember that like charges will repel, so because all these positive protons are the same, they all want to repel from each other. But the strong nuclear force is actually what's holding them together, and again, strong nuclear force is actually the strongest force in our universe. Okay, so that's number 9. Give me a green check when you have that saved. You have 1 minute. Again, if you're taking a picture, take a picture and still give me a green check. Go, go, go. 15 seconds left. Just waiting on Daylin, Dolly, Jacob, and Ty. Green checks if we're good on number 9, please. Now. All right, so again, skipping a few questions. Those will be in the video of the easy questions that I give you at the end of class. But right now, we're going to go ahead and skip down to question number 13. So remember, chemical energy, we learned about a bunch of different types of energy, right? We learned about mechanical, we learned about nuclear energy, electrical energy, and chemical energy, right? So there are lots of different types of energies that we talked about. So one, again, is chemical energy. And chemical energy is the energy that we store in chemical compounds, and when those compounds react, have chemical reactions, we release that chemical energy. So for example, batteries have chemicals inside of them that help to produce electricity in a flashlight. And burning gasoline allows us to produce motion in a car. So another really good example is a butane lighter. So butane is a chemical that reacts with oxygen, and the result is carbon dioxide, water, and heat. That's why you get fire from a butane lighter. So chemical energy stored in chemical compounds and then released in reactions. This is number 13. You have 1 minute. Green checks when you have it saved or you have taken a picture. Ready, set, go. Perfect. Just waiting on Angelina, Sienna, Dolly, and Haley, Jacob, Jasmine. Green checks, Ty, as you as well. Let's keep on going. Perfect, everyone. All right, so that being said, again, we also talked about mechanical energy, and mechanical energy is when we're talking about motion and position, so the energy of motion and position. And specifically, we break it down into two parts. So the motion part is kinetic energy. So this is the energy an object has because it's moving. Potential energy, on the other hand, means stored energy, and specifically when we're talking about mechanical energy, we're talking about its height, right? So we can see here that the higher up you are, like at the top of a roller coaster, the more potential energy you have. At the bottom, though, you have no potential energy and you're moving as fast as possible, which makes it all kinetic energy. This is number 14. Give me a green check when you have it saved. You have 1 minute. Take a picture and give me a green check, or save it and give me a green check. Ready, set, go. Okay, let me go ahead and take a quick look at it. Sorry, I don't actually have the questions in front of me right now, Kim, so give me 1 second. Right, still waiting on a few more green checks from everybody, though. So Ciara, Dalen, Dolly, make sure I get your green checks. Frankie, Jacob, Jasmine, Johnny, and Seha and Ty. All right, good. So we're talking about number 14. Yeah, so remember, Kim, hey, Dolly, please don't answer questions in the chat box. This is an exam. Okay, so remember that there are two types of energy, right? So motion means we're talking about kinetic. Position means we're talking about potential. Okay, does that make sense? Awesome. Cool. All right, let's keep on going. All right, so the next question is about kinetic theory. So we're talking about question number 15. And kinetic theory says that the movement of molecules is what causes heat. So that means in hot objects, the molecules are moving very, very fast. They have a lot of energy, and as a result, they're able to overcome the forces that are holding them together, right? They're sprinting, 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 and so they can actually escape from each other. So for example, liquids, the molecules in liquids will escape to become gases when they get lots of energy. And that is why gases are so hot. They have lots of energy. Cold objects, on the other hand, like ice, the molecules do not have a lot of energy. They're moving very, very slowly. So technically, molecules always move, right? It's just that they move much slower. They're just vibrating in place. So they don't have enough energy to escape, therefore they stay held together. This is number 15. Give me a green check when you have it saved. Ready, set, go. Awesome. All right, just waiting on green checks from Dalen, Dolly, Haley, Jacob, and Johnny. And Ty, green checks for number 15, and I'm moving on. Perfect. Okay, give me a smiley face, guys. How are we feeling about this so far? Do you guys feel like you're doing good on the exam? You understand what's going on? Hopefully I feel like I'm helping you. We're not just wasting time. Awesome. Good. Okay, so let's talk about radiation. Remember, there are 3 ways in which heat can move. It was radiation, conduction, and convection. Convection. However, radiation is kind of a special one because radiation does not need matter to travel. Remember, instead, it actually transfers its energy with electromagnetic waves, which do not need matter. They don't need atoms. They don't need anything to move. So, for example, sunlight is able to reach the Earth through empty space without any matter. Remember, in outer space, there's nothing out there. There's no air. So things like sound cannot move, but things like electromagnetic waves or light can. Okay, so where there's empty space, only electromagnetic waves can move through those. Now, again, this is different than conduction and convection. Remember, conduction requires you to be touching the object. Convection requires fluids to be swirling around. And so both of those are types of matter. They require actual molecules. Okay, smiley faces, if that makes sense of how radiation is different. Radiation does not require matter. Awesome. Okay, so this is number 16. Give me a green check when you have it saved. You have 1 minute. Ready, set, go. All right, Annalise and Dolly, make sure I get your green checks. Grant, Haley, Jacob, Jasmine, and Ty, green checks for number 16. And moving on. Okay, guys, so we are, again, skipping a couple of these because they are in the video I will be giving you in a moment. But let's talk about questions 17 and 19. 17 and 19 actually use the same graph, so that's why we're going over them together. So remember, when we're reading a graph, okay, we're going to take a look at the horizontal x-axis, okay, which is where we actually read up and down. Okay, so from the horizontal axis, you actually read up and down. Okay, the vertical axis, on the other hand, which is over here on the left, you read side to side. side to side. Okay, so for example, that being said, okay, the data at point A, take a look at the data at point A. Okay, so looking up, down, what time is this at point A? What time would this be? Look up and down and tell me what time would this be. Tell me in the chat box. Tell me in the chat box. I can actually draw a line here for you too. Yeah, so this is at 25 minutes, exactly. So at 25 minutes, then what is the temperature at 25 minutes? So now look left and right and tell me, what do you see on the temperature axis? Look left and right and tell me, what temperature do you see? Yeah, so at 25 minutes, our temperature is 40 degrees. Give me a smiley face if that makes sense how we got that. Smiley face if that makes sense how we got that. So at 25 minutes, our temperature was 40 degrees. Awesome, perfect. Okay, now what about point B? Take a look at point B right here. Okay, so up and down, what is our time? So what's our time here? Up and down. What is the time here? Yeah, this is going to be 50 minutes, exactly. And what is the temperature at 50 minutes? Now look left and right. Look left and right. Yes, exactly. Our temperature is definitely going to be 10 degrees. Yeah, and you guys are correct. It's Celsius, 10 degrees Celsius. 10 degrees C. Perfect. Okay, now take a look at point C, please. All right, so we're taking a look right here. Yeah, at point C. Where am I here? Okay, so at point C, all right, what time are we at point C? Tell me in the chat box. Again, take a look at the blue dot, Yes, exactly. So this is 40 minutes. And what is the temperature at 40 minutes? What is the temperature at 40 minutes? Take a look left and right. It's between 25 and 30. So what would be a good number between 25 and 30? I think it's actually a little bit closer to 25. So yeah, would that be? Yeah, I would say 27 probably, right? So this would be about 27 degrees Celsius. Okay, 27 degrees Celsius, okay? So this guy should help us answer question number 17. Okay, so first let's do question number 17. Go ahead, give me a green check when you have number 17 saved. I'll give you 30 seconds, and then we'll do number 19 together as well. So first do number 17. Perfect. Okay, guys. So the last thing is question number 19 asks about what's happening at 45 minutes. So again, where do I measure 45 minutes? Do I measure it down here on the bottom or down here, over here on the left? Where am I measuring for 45 minutes? On the bottom or on the left? Bottom or left? Yeah, 45 minutes is a time, right? So we're going to take a look at the time, right? So we're going to take a look at 45 minutes right here. So this right here is 45 minutes. And again, we're going to look up and down, right? So up and down to this point right here. And then once we look up and down to that point, we're going to go ahead and look over to the left, right? So looking over to the left, approximately what would be the temperature at 45 minutes? Approximately what would be the temperature? And you're going to have to round a little bit. The question does have you round a little bit. Yeah, so exactly. It's about 20 degrees Celsius. Smiley faces, guys, if that makes sense. This is about 20 degrees Celsius because first we looked at the time, went up to our trend line, and then looked at the temperature. So our trend line is helping us predict what the temperature would be if we had given 45 minutes of time. Awesome. So this is question number 19. Go ahead and give me a green check when you have question number 19 saved. All right, you have 30 seconds. Green checks. Go, go, go. 5 seconds, waiting on Annalise, Dolly, Jacob, Jasmine, Jeremy, Johnny, and Ty. All right, guys. So at this point, what I really want you to make sure, yeah, so at 45 minutes, right? So right here at 45 minutes. Yeah, it means after 45 minutes means like at the 45-minute mark, Kim. Is that what the question is? Sorry, I know that the way they say it can be a little bit confusing, but it means literally at the 45-minute mark. Okay? All right, cool, guys. Hello, students. This is the recording that goes over all of the easier questions on the final exam part 1. So going down to question number 6, remember that vectors describe two things. They describe both magnitude, which is the amount or the length of the arrow that you can see right here, for example, as well as direction, which tells you the direction or pointing towards which direction that the object is moving. So again, these arrows, they tell us both magnitude, how big the amount is. So in this case, 4 meters per second is bigger than 2 meters per second, so it's a bigger arrow. And the direction, it's moving to the right. So velocity can be a vector because it has both speed and direction, and forces can also be vectors because they have both speed and direction. So make sure, pause the video, answer question number 6, make sure you save it, and then let's move on. Question number 7 is talking about Newton's third law of motion. So remember that Newton's third law says that for every action or force, there's an equal and opposite reaction or force, and that these are going to actually be parallel to each other, right? So if our action is to the left, then the parallel opposite reaction would be to the right. Or for example, if you push a chair, if you push forwards while you're in a chair, the chair will move backwards. If you jump off the left, then the boat moves to the right. So every force has an opposing force. That's number 7. Make sure you pause, save your answer, and then move on. Question number 11 is taking us back to Pascal's principle. So remember that in a water bottle, which is a confined space, if we have a fluid inside of it, the pressure is going to be uniform throughout the entire container, which means it's the same at every single one of these points. So you can see all of these points have the same pressure. And if you try to increase the pressure at a single point, so for example by squeezing the bottle, you don't just increase pressure at that single point. Instead, Pascal's principle says that you also increase at every other point. So it's still a uniform or equal increase at all points of the fluid. So at any given point, even if you try to increase pressure, pressure is the same at every point in the bottle. So you can see here that as we squeeze the bottle does increase in pressure, it gets harder, but it does that all over. That's question number 11. Make sure you save your answer. Question number 12 is talking a little bit about circuits. So remember that a closed circuit means that it is an unbroken circuit, and therefore electrons are able to flow, right? So they can flow, and that means that the light will actually turn on, right? So when it's unbroken, that means that we can actually have electrons flowing through, which means that our light bulb will turn on. So again, closed means unbroken, means on. That's question number 12. Make sure you answer that, save your answer, and then move on. All right, so going down to question number 18, remember a lot of these questions we already answered in class. This is just going over the easier questions. So remember that we talked about mechanical advantage, which mechanical advantage is how easy it is to move an object. So when we talk about simple machines like levers and pulleys, what they do is they actually increase mechanical advantage to make it easier to move an object. And they do that by increasing the distance that you are from the other object, right? So on one side we can see that we have a big item that requires a big force, okay, but it only needs to be lifted a small distance, right? So it needs to be lifted a small distance. On the other side though, to make our lives easier, we can actually walk far away so that instead we have a big distance. And the result is the opposite happens with our force so that we can use a small force. Okay, so you should be able to see that these are opposites. So over here, we walk far away, we can use a smaller force. Over here, we would have to use a much bigger force to go a smaller distance. So that's what simple machines do. They kind of switch the story up. And the result is that even though we do the same amount of work, it feels much easier because we get to use less force on this side. So using less force means that we increase our mechanical advantage. We make it easier to move. This is question number 18. Make sure you answer that and save it. Now skipping number 19, going down to question 20. Question 20 is talking about waves. So remember we learned a bunch of different characteristics of waves, and one of those that we learned was wavelength. So remember waves do repeat in a cycle. So the length of one complete cycle from crest to crest or from trough to trough is going to be the wavelength. You can actually also measure this from the equilibrium. If you measure from where you're going down on the equilibrium to the next point at which you're going down on the equilibrium. So basically you can see 2 bumps here. 2 bumps is also going to be a wave. So again, wavelength is going to be crest to crest, trough to trough, or two of the bumps in the wave. That's question number 2. Question number 20. Make sure you answer that and save it. Question number 22, again, we're skipping a few questions because we've already answered them in class. Question number 22 is asking about is asking about work. So remember, there are 3 elements that are needed for work. We need a force, and that force is going to actually cause a displacement, okay, which means a motion, right? So the object does have to in fact move, and that motion is super important, has to be parallel to the force, okay? So for example, if your force is up, then the parallel motion either needs to be up or down. If your force is to the right, then your parallel motion should either be to the left or to the right. So for example, lifting an object up is in fact going to be work because your force is going up and the displacement or the motion of the box of the object is also going up. However, if we just kind of hold an object at the same height and then start walking around like you can see up here, this is not going to be work because we can see holding an object up means our force is up, right? So we have force going up. But in this case, if we're walking around, that means our motion is actually not parallel. So in this case, this is not going to be work. Okay, so again, lifting an object will be work. Holding an object and just walking around or just standing still will not be work because you have to have parallel displacement, parallel motion. That's question number 22. Make sure you answer that and save it. Question number 23 is talking a little bit about forces and acceleration. So remember, forces are a push or a pull, and what forces do, all forces are going to accelerate objects, meaning they're going to change their velocity. So we know, for example, from Newton's first law that an object at rest will stay at rest. So that means it doesn't move. It stays at 0 meters per second until an external force is applied. So we're going to apply an external force, and that's going to change the velocity. It'll speed up that ball. It will get that ball to start moving. So remember, acceleration is going to be any change in velocity. That means you could be speeding up. That means you could be slowing down because that's slowing down your velocity. It could also in fact mean that you're changing directions because remember, velocity also means also includes directions. Velocity is both speed and direction. Okay, so it does include both of those. All right, so make sure you save number 23. Question number 24 is talking about conductors versus insulators of electricity. So remember, electric currents are able to flow freely in a conductor, but they cannot flow freely in an insulator. So conductors, for example, are going to be things that we see over here like copper metal, and they are able to transmit the flow of electrons because they have a bunch of loose electrons in them, and so those loose electrons are able to carry that electric charge very easily. Insulators, on the other hand, inhibit or stop the flow of electrons, like plastics and rubbers, okay? And that means that these are really good at stopping electricity. So again, metals are usually good conductors, nonmetals are generally good insulators. This is question number 24. Make sure you save your answers. Question number 25, last but not least, is talking about the Doppler effect. Remember, Doppler effect has to do with the frequency or pitch that you hear when a sound is moving towards or away from you. And this has to do with that idea of an ambulance or a fire truck coming towards you. Now, when it's coming towards you, you actually hear a much higher pitch. And the reason for that is because these sound waves are actually pretty slow. And so what happens is that as the ambulance moves, it moves faster then the sound waves can really keep up. So what happens is those sound waves get pushed together, and that's going to push together the sound waves, make a higher frequency and therefore a higher pitch, which again you can see up here, moving close together, making a higher pitch. Now, once it passes you and starts moving away from you, we heard in the video in class that suddenly the sound drops really quickly, right? We go to a lower pitch. And the reason for that is, again, because sound waves are pretty slow. As the ambulance moves away from you, those sound waves cannot keep up as easily. So they begin to spread out, and spreading out means it's a lower frequency, and therefore you observe a lower pitch. Okay, so that's question number 25. Make sure you save your answer. And that is all of the easy questions. I will see you guys later. So that being said, guys, this was our objective for today. Okay, now what I really want you to do, I want you to make sure you scroll all the way down. Okay, and make sure you click where it says save all responses. So you see that blue button, it says save all responses, smiley faces if you guys have saved all of your responses. Okay, because now I'm going to give you the video that goes over the easy questions. Yeah, Kim, it says, what's the temperature after 45 minutes, meaning after 45 minutes have passed, so we measure at 45. Does that make sense? It's not asking about like at 50 minutes. Yeah, okay, good. Gotcha. Cool. All right, guys. So that being said, I'm going to go ahead and give you a recording. It's 10 minutes, and this recording goes over all the easy questions. Smiley faces if you guys feel good about that. Smiley faces if you feel good about that. Okay, so let me grab this. Awesome, guys. And this recording will also be included in the 10A recording. So don't worry if you guys like lose the link or something. It will be uploaded to the actual course page as well. It's just included in today's recording. Okay, guys? Perfect. All right, so here is your last word. If anyone came in late, let me get you the attendance ticket. Here we go. And you guys are good to go. Thanks so much, and I will see you all later. Bye, everyone.